So what your topics are, so I think I'm sharing my iPad screen. It appears to me that I am. If you're not seeing it for some reason, let me know, and we'll explore why that may be. Your topic for this week, if your class is following along with the typical calendar, is circles and ellipses. And those are two types of conic sections. We'll spend the next couple of weeks of the class looking at conic sections in detail, plotting, graphing the equation or graphing the conic sections, identifying characteristics about the conic sections, and it'll be just a really detailed exploration of all of the conic sections. This week, though, you'll start with circles and ellipses. Just kind of a generic overview of each of those. A circle, of course, is the collection of points that are all the same distance from a given point. That given point would be the center, and all of the points that are the same distance away create the circle. So what we're talking about there is the radius. So the collection of all points that are 4 units away from the circle, or from the center, creates a circle. An ellipse, a little bit more detailed of an explanation, but it's an oval shape. It's sort of like an elongated circle. So if you just think of the circle and you stretch it out either vertically or horizontally, that's an ellipse. And there's not the biggest thing that we're going to talk about today is completing the square. That's going to be a really important part of working with the two conic sections this week and the two coming up next week, hyperbolas and parabolas. But being able to complete the square is something that may have come up in your 171 class. It depends on how your quadratic section was taught, your applications. But completing the square could have come up back then, and that's what we're going to look at today. But it will certainly come up in a lot of your conic sections over the next couple of weeks. So what I just put a screenshot in the chat, and there's a picture of a PowerPoint slide, but that's more phrased in terms of a 171 approach to completing the square. We're not so much going to be working with functions for our conic section this week, but we'll at least practice with completing the square first from a function standpoint, because that's how you would have perhaps most recently seen it. And then we'll tie that into circles and talk about how we can use that to create graphs of circles. All right, so we're going to actually do 3 examples because completing the square can sometimes be a tricky task. But first, I need to turn my phone on silent. Sorry. Too many notifications. I couldn't click on the settings. All right. Completing the square. So let's say we have the function f of x equals x squared plus 10x minus 17. What we mean by completing the square is that eventually we want to have that function written as x minus h squared plus k. We need to figure out h and k. Completing the square, so completing the square part, we're talking about a perfect square as part of the way the function is expressed. And so the screenshot I sent has 5 steps that you can follow at a point. You may not necessarily need to differentiate each of these. It's really just one continuous process. But what we need to do first is move that 17 from the end. We need to move it to the other side with the f. It's not really part of the completing the square process, so we're just kind of scooting it over out of the way. And then what we do is add a new term to each side of this equation. I'm just going to add the new term in front of everything on the left. But the new term we add is always half of that, the coefficient with x, it's half of that and squared. So in this case, half of 10 is 5, and 5 squared is 25. So we're going to add 25 to both sides. And what that does on the right side, x x squared plus 10x plus 25, that's a perfect square now, and it factors into x plus 5 squared, right, which kind of checks off the box. We have the first portion of the equation I wrote over there in red. We at least have that perfect square part. On the left side, we can combine the 25 and the 17 to get 42. And then our last step is to move the 42 to the right-hand side in place of essentially becoming the k from the red equation that I wrote. So we'll subtract it to the right side to get f of x equals x plus 5 squared minus 42. Questions about anything that we did with that one? Okay, let's look at one that's got one additional step. The one we just looked at did not involve step 2 from the list I sent, but this one we're about to do will involve step 2. So g of x equals 2x squared minus 8x plus 9. Same first step. So we need to complete the square for this. Our first step is the same. We're going to move the 9 to the left side because it's not part of our completing the squared journey. We can only complete the square if the coefficient on the x squared term is 1. Right, so that's why back here for the one, let me do this in another color. For the one that we did just a second ago, the reason we didn't have to factor out, the reason we could complete the square at the beginning is because that coefficient is 1. But currently for the one we're working on with g, that coefficient's a 2. So that's where step 2 comes in the list I sent. So what we'll do next is actually factor out a 2 from both of the terms on the right side. Then we can add the new term to both sides. Just like before, the term we add on the right side is half of negative 4 and square it. So half of negative 4 is negative 2. Square it to get positive 4. Whatever we add on the right side, we've got to add on the left side. But just notice what we're adding on the right side. It's not 4. We wrote a 4, but what we're actually adding is 2 times 4, since that 4 is inside of a set of parentheses with a 2 in front of it. So we're really adding 8 on the right side, which means we need to add 8 on the left side as well. But what that does, we now have the perfect square on the right side. It's 2 times x minus 2 squared. The left side, or on the left side, we can combine the negative 9 and 8. That gives us g of x minus 1. And then we can add 1 to both sides to put it back in standard form, as that's what that is, to get g of x equals 2x, 2 times x minus 2 squared plus 1. Whoops. Into that. Questions about g? If not, I wrote one more. I'm going to give you a couple of minutes to try that one if you will. We'll go over it together, of course, in a second. If you have questions while you're working, you can definitely let me know those as well, but just wanted to give you a chance to try one. It's similar to 2 in that it has the coefficient that eventually we need to factor out. I'll give you a moment to try it and then we'll chat about it. All right, let's see. So first we'll move the 20 to the left side. At the same time I do that, I'm going to go ahead and factor, well, let's not do it at the same time. The next step is going to be factoring out the 3 on the right side. So I'll do that now. We should factor out a -3 from both of the terms on the left side. We factor out the -3 from -3x squared, it leaves us with x squared. But factoring out the -3 from the 18 leaves a -6. Then we can add the new term to both sides. It goes inside the parentheses on the right, it just goes on its own on the left. To get that new term, we'll take half of -6, that's -3, and square it to get 9. On the left side, we have to add exactly what we just added on the right side. And on the right side, we're really adding -3 times 9, which is -27. So that's what we've got to add on the left side too. That gives us on the left side h of x minus 7, and it's equal to -3 times x minus 3 squared on the right. And that's our perfect square over there. Last thing to wrap this up is to move the 7 to the right side by adding it. Questions about any of those? So there's a very good chance you've seen circles in the past in some other math class. Not in 171, but there's a good chance at some point in the past you did see them. So we're going to talk about those as well. This will be pretty related to is likely to be pretty related to the conversation you'll have this weekend, actually in your 172 class. But the standard form for the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. H and k tell us the center, they're the ordered pair for the center of the circle. R is the radius. So one of your tasks for the week, a big part of your task, or one of your biggest tasks, is going to be taking these equations and actually creating the graphs of them. Let's say we have the equation x minus 3 squared plus y minus 4, squared equals 4. In order to graph this, we only need to do two things. We need to identify the center, and we need to identify the radius. The center is literally at the ordered pair h and k. So in this case, that's 3 with 3, 4. It's not, just to point out, it's not -3, -4, just because notice that the equation, the standard form, already has negative signs there. So h and k, in terms of like exactly what you see inside of these parentheses, h and k are technically the opposite of what you are visibly looking at. You see x minus 3, that means the center is at +3. Y minus 4 means the center is at +4. So our center's at 3, 4. And the radius, it's the square root of whatever number's on the right side. Remember, this number is r squared. So the radius is at the square root of that value. In this case, that's 2. So to create the graph, all we need to do is go 3 units to the right, 4 units up, and then draw a circle that has a radius of 2. So that means we could go left 2 units, we could go right 2 units, up 2 units, and down 2 units. Connect the dots. I didn't really connect them all that well. Connect them as best I can with a little tip on this pen. But there's our circle. Questions about that one? If not, I wrote a second one here. I'm going to give you a moment to try doing the exact same thing. The center is at the ordered pair h with k. That's the opposite of 2, so -2. The opposite of -5, so +5. And then the radius is the square root of 9, which is 3. To create the graph here, we'll go 2 units to the left, 5 units up, and then left, right, up, and down 3. So 1, 2, 3 to the right, 1, 2, 3 to the left, 3 up, 2, 3, and 3 down, 1, 2, 3. We'll connect the dots. That doesn't look too circular. That's dang, 1, 2, 3. So it's definitely supposed to be a circle. My points have it's obviously not stellar because I'm trying to do it on this little screen here, but it's certainly our idea. Questions about that one? Okay, so let's look at this from a different perspective. Now, this one will actually require us to complete the square. X squared minus 4x plus y squared plus 2y equals 11. So this is the specific context where you will be completing the square for the week in 172. The task, remember, is to generate an equation. Let's see if I can erase. That looks like x minus h squared plus y minus k squared equals r squared. So what that means is we need to have a perfect square for the group of x's and a perfect square for the group of y's. To make it happen, we'll complete the square 2 times. First with the group of x's, we'll add a new term there. And then to the group of y's, we'll add a new term there. Let's do it in pink. What that means, though, is that we need to add a new term, 2 new terms on the right side, one for the group of x's and one for the group of y's. But how we treat each of those groups is exactly the same as what we did above. For the x's, we'll take half of -4, that's -2, and square it, to get +4. For the group of y's, we'll take half of 2, that's 1. 1 squared is +1. That means we need to add 4 and 1 on the right side as well. With the x's, that gives us x minus 2 squared. With the y's, it's y plus 1 squared. On the right side is equal to 16. Now that the equation is in standard form, it exactly matches what's in red. If we wanted to graph it, we could. For now, we'll just identify the center and radius. We didn't graph the ones above. The center is at 2, -1. Again, the opposite of the numbers you see in the parentheses there. The radius is the square root of the right side, which is 4. Questions about anything we did for that one? Ugh. If not, I'm trying to copy another one to give you a chance to try this one. See if you can complete this square for the x's and y's here to write the equation in standard form. So for the group of x's, we need to add a new term. For the group of y's, we also need to add a new term. And that means on the right side, we need to add 2 new terms. One for the x's and the one from the y's. For the x's, half of 10 is 5, and 5 squared is 25. For the y's, half of -4 is -2. Square that to get 4. So on the right side, we'll also add 25 and 4. That means for the x's, we now have a perfect square, x plus 5 squared. The y's are a perfect square too, y minus 2 squared. And the right side, 25 looks like 44. 25, 30, 44, yeah. So in terms of the center and radius, center is not going to be too bad. Radius either, I guess, but not a whole number anyway. The center is at -5, 2. The radius is the square root of 44, which is 2 times the square root of 11. Questions about anything we did with the circles there? Like I said at the beginning, your task for these conic sections is going to be to create graphs. To do that, you're going to use characteristics of the conic sections, and the convenient thing about circles is that there's only 2 characteristics, the center and the radius. So that makes these a really good starting point for the discussion, for all of the discussions to come later for all the other conic sections. So ellipses are really closely related to circles. I actually described it earlier as an elongated circle. So we're going to talk about the graphs of an ellipse, or the graphs of ellipses. There's a whole lot more to the story than just the graphs. There's a whole list of characteristics you'll discuss in your 172 classes for the week. But since they are so closely related, at least in terms of creating graphs, we'll talk about at least that part of them for now. So the standard form for the equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So it looks a little bit like the equation of a circle, at least some aspects of it. We have the x minus h squared and the y minus k squared. We'll talk about how a and b come into play in just a moment when we look at one. The one on the right side, it's always going to be there, so there's not actually anything that really comes from that, except we just need to, if we have something in this form with a 1 on the other side, then it is an ellipse. Okay, so the center, it's the exact same thing as the ordered pair HK, which in this case is 2, -1. Let's see, I normally have a blank graph in here. Yeah, let's use this. So, in order to create the graph of this, what we'll do is go over to the center. It's at 2, -1. And then just like with the ellipse, remember, or with the circle, remember when we were creating the graph, I said let whatever the radius was, the last one we graphed had a radius of 3. So I said we'll go left 3, right 3, up 3, down 3. For the ellipse, we'll still move in similar ways, but we're not going to be moving the same distance up and down as we are left and right, but that's the only difference. So what we'll do with the ellipse is whatever number is below the x's, the square root of that tells us how far left and right we'll go to get to the outside of the ellipse, which in this case is 2. So we'll go 2 units to the right and 2 units to the left. Whatever number is below the y, the square root of that tells us how far up and down to go. And I'm actually going to go back and make my points. I'm going to do them in red and blue. So color code them a little bit. So down 3, up 1, 2, 3. And that generates the graph of the ellipse. Questions about the one we just did? Because if not, I'm going to give you a second to try graphing this new one that I've written below. So the center, it's at the opposite of 1 and the opposite of 8. -1, -8. The square root of the number below the x tells us how far left and right we should go. The square root of 25 is 5. The number below the y, the square root of the number below the y, tells us how far up and down we should go, both of those with respect to the center. So from the center, we'll go 5 units to the right and 5 to the left. We'll go up 7 and down 7. I'm going to be off of the grid there, but somewhere around there, maybe a little lower. Once we have those 4 points, we can connect the dots to generate the graph. So I have one more for us to try. Again, I'll give you some time to have a shot at that one on your own, using the center and then the denominators from the fractions to create the graph. So the center is at the opposite of 3 with the opposite of -2. Oh, gosh. According to the denominator for the x's, we should go left and right the square root of 64, which is 8. According to the denominator with y's, we should go up and down 4. That's the square root of 16. So left 8 and right 8. Up 4, down 4. 1, 2, 3, 4. 1, 2, 3, 4. Gives us that for our ellipse. Questions about anything we've done? All right, so that's actually what we've got planned for the day. There's not a ton of prerequisite stuff for the conic sections as far as finding the characteristics and all that stuff. You'll have a lengthy list of characteristics and you'll work through those in your 172 classes. We've touched on as much as I could possibly connect to prerequisite things and some things that maybe were a stretch on my part. So I put the link to our second survey in the chat. If you'll complete that before you leave, I would sincerely appreciate it, as always. But for the rest of our time, if you have any questions about anything you want to talk about, anything you're working on, we can stay and do that until for as long as you want. But feel free to stay as long as you want or to go whenever you get ready. We've covered everything I've got planned, and the rest of the time is for questions you've got for me.